Welcome back to lab. Today we're going to talk about strings and vectors. But first, we're going to start with a code tracing exercise. So here we have shown a C++ code sample on the screen and the input file associated with it. Your job is to read and trace the code and show us the output, what's being written into the update.txt. So I encourage you to pause the video right here and try to figure out the output yourself. And we'll reconvene afterwards to reveal the answer. The correct answer is I love animals that start with F. Did you get the right answer? I encourage you to visit office hours or make a post on Piazza if you don't know why this is the correct answer. Next up is strings. Strings are words. We can think of them as a string of characters. So in the code snippet that's showing on the screen, in the first two lines inside the main function, we declare two strings. The first string has the variable name first, and it stores Chang, which is my first name. And the second string has the variable name last, and it contains my last name. We can access the individual characters inside those strings using the @ function or the bracket operator. So for example, here, letter H is the first character inside of the first string. Remember, in C++, we start indexing using 0. So the first character inside of the string is actually H. Similarly, we can use a square bracket to index into the string. So for example, here, the fourth character inside of the string Chang is G. Okay, so these are character variables, and we can print them out using cout. So again, the letter H and letter G are two variables that we're printing out to the terminal. There are a lot of functions that's associated with the strings. Remember to include the string header file when you're using those functions. A lot of them are very useful. I have listed a few that you should know. If you don't know what they are, I encourage you to look them up on Google. And if you still have trouble understanding them, please come to us during office hours and we'll be happy to explain to you what they are. Next up, I'll show you how to build a string by walking you through a coding example. So here, let's create a function that create a chain of dollar signs. So first, let's think about what's the input to our function, right? So here, the input to our function is simply the number of dollar signs that we want. Okay. Next, let's think about what are the outputs to our function. So here, the output is just a string that contains a lot of dollar signs. Here we have a empty C++ file with the scaffolding already written in. Let's go ahead and start creating our money function. So here, we start with the return type, which is a string. The function name is money, and as we talked about earlier, we take in one integer as an argument. We can start with an empty string and then append dollar signs to it. Now we can use a for loop to append dollar signs to the output string. So we count from 0 up until the number. We are going to append a dollar sign to out. Okay. So once we do that, we're going to return the output string as the return value. So from here, we can go ahead and call the money function. We can directly put that in a cout statement so that our money string will be printed to the output stream. Okay. So from here, we can go ahead and compile our code. So we can go ahead and run the money code. We can see that it prints out $10 signs. Next up, I want to talk about find and replace. and I want to introduce find using another coding demo. So let's write a function together to determine whether a tweet is about Trump. So here the assumption is if the tweet contains the word Trump or president, then it's about Trump. So again, let's first think about what's the input to our function. The input here is a tweet, which is a string. And next, let's think about the output to our function. Right? Here, the output is a boolean, right? Either true or false, whether the tweet is about President Trump or not. Here we have a C++ file with all the appropriate headers included. One of the new headers we can see is the string. Let's go ahead and start writing our function. Our function takes in a string as input and it returns a boolean. Okay. So here I have created a function header. So our function headers start with bool, which is our return type, right? We're going to return a boolean. And here we're going to take in one string as input, which I'm going to call it tweet. We can use the find function to find whether the word president or Trump is contained inside of our input tweet. So we can go ahead and use an if statement. If tweet dot find president okay, so here the condition is tweet.findPresident not equals tweet.mPos. So tweet.findPresident here will return the first place in the tweet where we find president. If president is not contained within the tweet, it will then return the mPos. So we can think of mPos as -1. So if tweet.findPresident is not the mPos, that means the tweet contains the word president. Okay. If that's the case, we know that the tweet is about the president. We can go ahead and return true. Okay. If that's not the case, we can then check for the word Trump. So else if tweet find Trump not equal to -1. So here I just wanted to demonstrate that mPos and -1 are somewhat interchangeable. So I'm going to use -1. So here, if we could find the word Trump inside of our tweet, we can go ahead and return true. Okay. Otherwise, if none of these two cases are true, then we can go ahead and return false. So now we have our function implemented, we can go ahead and call it. We can actually call the function within a cout statement, so we can print out whether our tweets is about President Trump. So we can go ahead and cout is Trump, hello Trump. So our first function call checks whether the tweet hello Trump is about President Trump. So we expect a true here. So when we print the Boolean value to the terminal, it will print out 1. Okay. And we can do the same thing. Instead, we can use president. Right. So again, we expect a 1 to the terminal here. Suppose we can check a third tweet that doesn't have the word President or Trump inside of it. So we expect a 0 here for the output. So we expect the output to be 1, 1, and 0. Okay. So let's go ahead and compile our trump.cpp. Okay, let's go ahead and run it. As we can see, we get our expected result, 1, 1, and 0. So if you have any questions about this demo, please feel free to contact us in office hours or on Piazza. Next up, let's talk about replace. So the code snippet shown here on the screen will output I love C++. So let's see how it does it. First, we'll declare a string that contains I hate C++. and then we declare a string, the replacement, which has the string love. So first, we find the word hate in the word string, right? So we find the index where it starts. Next, we use the replace function. So the replace function takes in 3 arguments. The first argument is the position of the first character to be replaced. The second argument is the number of characters to replace. Okay, and the third argument is the replacement string. So here we're replacing starting at the index where the word hate starts, and we're going to replace 4 characters, and we're going to replace these 4 characters with the string love. So if we see out the word after the replacement, we'll get I love C++. Next up is vectors. A C++ vector is just like a MATLAB row vector. It can contain only one type of data. So here we use an angle bracket to specify the type of data that's contained in this vector. Here is an example that we can construct a vector by pushing back values one by one. So in the code snippet showing on the screen, we first declare empty integer vector odd numbers that doesn't have anything in it. And then we push back each element one by one in the order that they will appear in the vector. So at the end of the code snippet, we will have 4 elements in the odd numbers vector, and then it will be 1, 3, 5, 7. Here is another example. Again, we push back elements into the vector vec one by one. So in this case, we have 3 elements, 0, 10, and 20. What we can do here is we can use the .at function to access individual elements inside of this vector. So for example, if we do vec.at1, we'll receive 10. If we want to access the last element in the vector, then we need to do vec.size minus 1. And here's why. Vec.size returns 3, right? There are 3 elements inside of this vector right now. So if we want the last element, it's actually 1 less than 3, since C++ indexing starts at 0. So vec size minus 1 give us 2, which is the last element inside this vector. So therefore the output to the code snippet will be 10 and 20. Next up is getLine. Reading from an input stream, whether if it's a file stream or a cin, using the extraction operator will always stop at a space. So this might cause a problem here. Suppose we want to reading superheroes shown here on the screen line by line. We'll actually stop after Captain and before America. And that's not a good thing because Captain America is one superhero. So the solution here is to use getLine. So again, if we use cin, it splits Captain and America. So if we use getLine, it will actually get the entire line and stop at the end of Captain America. The getLine function takes in 2 input. The first one is cin, which is the stream that you're reading from. And the second argument is the name of the variable that you're storing the result to. Okay, so you might ask, how does getLine actually modify our variable if we don't see any assignment that's going on here in our code? That's a very good question, and the solution is pass by reference. When we're using the getLine function, we don't need to assign the output to a string variable. And that's because getLine function takes the string by reference. So a possible declaration of the getLine function might be it takes in 2 arguments, both by reference. Right? The first one is the string, and the second one is the string. It reads from the string and assigns to the string. Okay? The getLine function will return a boolean, whether it was able to successfully read a line from the string. And this return value is very helpful when we're trying to read every single line in a file. So that's all the content I want to cover today. Today we briefly covered strings and vectors in getLine. To turn in today's lab assignment to Canvas, you need to submit 2 C++ files. They are due on April 7th at 11:59 p.m. You have a weekly review due this Sunday as usual. And Project 5 has been released. The project design is due on April 3rd on the Grayscope, and the code is due on April 8th on the AutoGrader. Next week, we'll talk about vectors of vectors and structs in C++. See you next week.